Hello, everybody. Right. So, hope everyone is having a good time so far. So, this is the next Shiny for Good session, and we are having Charles Scarborough with us. He is an air quality data scientist at Sonoma Technology, where he conducts analysis related to air pollution exposure, impacts of air pollution, and wildfires. He has developed and is currently maintaining Shiny dashboards for the US Environmental Protection Agency, EPA, and we're super excited to have him here to share his work with us.
Hello, everyone. I'm Charles Scarborough. I'm a data scientist at Sonoma Technology. We're a consulting company in Northern California, specializes in air quality. Today, I'm going to be demonstrating the Smoke Path Explorer tool. This tool was developed in partnership with the California and Nevada Smoke and Air Committee, the Desert Research Institute, and it was funded by the California Department of Forestry and Fire Protection. So I'll just provide a bit of context for this tool. California and other Western US states have seen a historic rise in the intensity and size of wildfires over the past 20 years, due in part to climate change, but also due to hundreds of years of fire suppression practices. The accumulation of biomass due to fire suppression has provided hazardous fuels that in part led to these devastating wildfires. Prescribed fires are one of the most effective tools to reduce the buildup of hazardous fuels. In California, it's expected to increase fuels treatment activity, including the use of prescribed fires to address this risk. However, any biomass burning emits air pollutants that can adversely impact public health, but prescribed fires are done in a controlled manner to minimize smoke impacts. Land and air quality managers currently lack easily accessible tools to help plan for future prescribed fires and the subsequent downwind impacts. To address this, we developed a highly interactive Shiny dashboard to assist land and air quality managers in long-term smoke management planning. The dashboard gives users the ability to quickly model and visualize the probability of smoke impacts from a user-selected location based on 20 years of data, and that is from 2001 to 2020. This is of gridded historical weather data. So in summary, the results answer the three questions that follows. The first is, what is the probability that air from the starting location or the location of the fire will reach any other location within the gridded map domain within the first 24 hours of ignition? Second question is, what is the risk of smoke impacting sensitive communities? And the third question is, what do the relevant fire weather statistics look like at the location of the fire? So to develop this dashboard, we used Amazon's S3 cloud storage to store historical gridded weather data and climatology data. These data are read in quickly using the Arrow package and processed based on user inputs. The Shiny dashboard presents the smoke impact results in spatial and tabular formats. So I'll go into the dashboard now, and I'll talk about the layout. And I should mention that this relied heavily on the base Shiny package, but was also developed with the Shiny dashboard package. When the user accesses the dashboard, they'll be shown a pop-up, as you see here, with general information and a link to the user guide. Below that, the user can select the time period that they want to model. We included preset configurations based on the current month or week. The user selections are shown in the box to the right with additional messages and other warnings. The leaflet map here is the main component of the dashboard. The user can zoom to a location or click on the map to select the initialization location. I've zoomed to these coordinates and clicked on the point. The map shows the selected location and the closest grid cell within the gridded map domain. So if I click around, it'll change where these points are. Once the user has the select starting location of the fire in the time period selection, they'll click on the first action button, which I've already done. This will trigger the dashboard to pull the appropriate data from the S3 bucket via the arrow package and compute the probability calculations. The contours will pop up on the leaflet map, and it's important to understand that these contours do not show smoke plumes, but rather the probability of air transport. And I'll talk a bit about this example that I've preloaded. And it shows that air initiated at this location under these user-selected conditions is very likely to travel north away from the small city of Redding, California, Northern California. However, there are still some risks over Redding since the likely contour, this blue contour here, stretches to cover the city to the south. The user can toggle the sensitive communities, what we call receptors, on or off to see which ones fall into the probability category. Below the map are two boxes. On the left is the meteorology or the fire weather climatology statistics that are based on the user-selected time period and location. The question mark icon gives vital information on the meteorological variables displayed here. The climatology analysis is important because it gives users information about environmental conditions around the time that they would be planning a prescribed fire. So if conditions are shown to be unfavorable, like if it's very hot or windy or dry, it may not be a good idea to do the prescribed fire. The next step in this is to count the potential sensitive communities that may be impacted by smoke. So the user will click on the second action button here to count the potential receptors that fall into the respective probability categories, which are shown here. The population, healthcare facilities, educational facilities, and zip codes will be added up based on which contour level they fall into, like you just seen. And zip codes will also be listed below based on the probability category. Another question mark icon gives the source of the data. So once the user has ran all these analyses, they can generate a report using the button up here. I'll just click on the PDF report and it'll provide a generic name unless the user specifies to the left here. And that is it. Thank you. Hello, everyone. I'm Charles Scarborough. I'm a data scientist today.
All right. Hope we all enjoyed that session. And we have the keynote in stage 1 in a few minutes. So please take the time to have a quick break, and then we'll see you in stage 1 for our keynote. Bye.